All right, hey guys, continuing to look at chapter 10, this idea of quadratics. Again, a quadratic is just anything that involves an x squared or a p squared or whatever as its highest exponent. And today what I want to look at is we're going to break 10.4 up into a couple days. We're going to look at another way to solve these quadratics. Right now we've got a couple different methods. One is by factoring and using the zero product property. We've also looked at how to graph these things and solve them that way. And today we're going to look at how to solve these things by using square roots. All right. And you notice in each one of these, now this is a kind of a special case here, but in each one of these, I don't see an x term. I don't see a b. All right. I've got x squared. I've got my constant. I don't see an x. I don't see anything involving just p. Here, I don't see anything involving just h. All right. A lot of times in these quadratics, we'll see ax squared plus bx plus c, and I don't see that x term. As soon as I see that, that is kind of your clue to, hey, let's see if we can use square roots to solve this. All right. So we're really going to solve this like we've always solved equations. If you want, for old time's sake, let's draw that honkin' tonkin' line, and let's get x by itself by using the opposite operations. All right. And again, even do an order of operations in reverse. So I've got multiplication going on here because I'm multiplying by 3, and I've got an exponent. Again, order of operations would say do the exponent first and then multiply by 3. Since I'm undoing this problem, I'm going to do that backwards. So I'm going to do the opposite of multiplying by 3. I'm going to divide both sides by 3. And so here I get x squared, and here I get 9. And then when I'm looking at this now to undo a square, again, I want to do the opposite operation for that. So if we think about, just like with multiplication, the opposite of multiplication was division. All right. So to do the opposite of a square, all right, I want to do the opposite of that. The opposite of squaring is square rooting. And again, that's perfectly okay as long as I do it to both sides. So the square root of x is x, okay? And now, I get x equals 3, all right? Now, just really what we need to look at here is, and we could take a closer look at this a little bit later, but if I'm looking at, we got one of our solutions here. Now we know with quadratics, I'm typically talking about two different solutions here, with these. Well, if I go back to this equation, x squared equals 9, and I'm looking for values of x that make that thing true, what number squared would equal 9? Well, obviously 3 is one of them, but there's another one. All right. And in this case, it's -3. All right. So in doing the square root of both sides, we're going to get two different answers here. The positive answer, called the principal square root, and then its opposite. All right. So in this case, we get 3 and -3. Now, again, these are solutions to this equation. If I plug them in, 3 squared is 9, times 3 is 27. If I plug this one in, it makes the equation true. -3 squared is 9, times 3 is also 27. All right. So we still are expecting two solutions here. You just have to remember when we take this step here that you're always going to get the positive and the negative of that. Okay. But again, it's just solving these things by doing the opposite and doing it to both sides. It's just now this opposite could involve a square root. So if we look at this one, all right, honkin' tonkin' line, I subtract 12 on both sides. I do addition and subtraction first. These are going to zero out just like they have in the past. So I get p squared equals 0. And now I do the square root of both sides, and I get, well, square root of p is p, and the square root of 0 is 0. Now, again, typically I would get two answers, but there's no such thing as the opposite. There's no such thing as -0. So we have seen quadratics that only have one solution. All right, this particular parabola would only cross the x-axis once, right at the origin. Okay, right at 0. So we've seen that. Okay, so sometimes we get two solutions, and we've seen parabolas. Let me sketch this one real quick. Okay, probably looks something like this with one intercept at -3 and one intercept at +3. We've seen parabolas here that have one solution. All right, this one would probably look something like this. All right, with only one solution, with only one x-intercept. Okay, and now so I solve this one. Draw my honkin' tonkin' line. I add 3 on both sides. I get a squared equals -1. And now here I would, again, this is where I would take the square root of both sides. But, all right, wait a minute. So the square root of a squared is a. Square root of -1, don't type that in your calculator. It'll explode, right? It doesn't exist, right? So there is no square root of -1, at least not in the real numbers, all right? So this one has, we say, no real solution. Okay, and again, we've seen that with quadratics. All right, this quadratic, if I would graph this parabola, probably looks something like this. All right, where it never crosses the x-axis. You still are going to get all three kinds here with two solutions, with one solution, maybe with no solutions at all. But it's all about doing the opposite and doing it to both sides to get the variable by itself. Here. Again, 25h squared equals 49. I draw my honkin' tonkin' line. I'm going to divide both sides by 25. Now, instead of dividing this, because it's going to come out, if you do that on your calculator, it's going to come out ugly. I'm just going to leave it as 49 25ths. It's okay to leave that as that improper fraction. All right. Now, if I want to solve this, the opposite of squaring something is square rooting it. Okay. And if I do the square root of 49 25ths, sneak peek here, I'm going to give you a little hint. If we think about how fractions are multiplied, if I want to do the square root of a fraction, I can actually just do the square root of the numerator and the square root of the denominator individually. All right, so you could type this in your calculator. It may give you a decimal. I would suggest you change that to a fraction, and I bet that fraction is going to be 7/5. Square root of 49 is 7. Square root of 25 is 5. Okay, so we get 7/5 or -7/5. Again, we get that other answer. And again, a lot of times or sometimes you might see that written like this. This little symbol here means positive or negative. All right, you can write it this way, or you can write it with that symbol there, a plus sign. It looks like an underlined plus sign there. It's just positive or -7/5. Now, some of them are going to get a little bit trickier here. All right, it almost looks like a two-step here. Smell that? All right, so I do addition and subtraction first. I add 10 to both sides. So these are going to zero out. I get 2x squared equals 16. I divide by 2 on both sides. I get x squared equals 8. And now I do the square root of both sides. I get x. Now, when I do the square root of 8, now again, my calculator is going to look a little bit different from yours. But again, square root of 8 doesn't change regardless of what it is. If I do the square root of 8, it doesn't come out even, all right? It's going to be a little bit less than 3. I know that because the square root of 9 is 3. So it's that. Holy cow, this is an irrational number. It's going to go on forever. So let's round this to 2 places past the decimal. So x is, and I'm going to use the approximately because we are doing some rounding here, it's about 2.8, 2 and 83 hundredths, okay? Or again, it would be that -2 and 83 hundredths. Okay. All right, so just this idea here of solving quadratics, just another way to solve quadratics using square roots, using the inverse operation. All right, whatever I do to one side, I have to do to the other. Just do keep in mind here that when you do take the square root of both sides, you get 2 answers here, which a lot of times we expect with quadratics. We expect them to have 2 x-intercepts. All right, your homework is down here. I'll be posting that on Classroom here shortly, okay? Or make sure you get those answers shared on Flipgrid. I'll be getting those answers shared for you. Let me know if you have any questions, okay? Look forward to hearing from you guys. Take care.